This last theorem I think is just kind of a silly theorem because it seems pretty straightforward, and honestly it's not something that you're going to come into contact with a lot, but I'm going to go ahead and give it to you. So the theorem itself basically says if you have three functions and you know that one function is always less than the other two, one function is always greater than the other two, and the other one's always in the middle of the other two, then you can use the squeeze theorem if we're finding the limit of the middle function at some given value. If the function of the one that's always on top, the limit of the function of the one that's always on top, and the limit of the function of the one that's always on the bottom, if that limit is the same, then the limit of our middle function is also going to be the same, which makes sense, especially if you're looking at the picture over here. The top or greater and the bottom or less than function, if they squeeze together and are suddenly the same at a certain point, then if we know that this guy is always in the middle of those, then we know that's going to have the same limit as well. Again, pretty straightforward and silly. So again, here's how we might see that. We have 4 minus x squared and 4 plus x squared, which would be like our lower and upper function. And if I'm finding the limit as x approaches 0 of these functions, and the limit of each of those functions is 4, even though I have no earthly idea what the function f of x is, I know that that limit must be 4. Last thing we're going to talk about is special trigonometric limits. So these, again, this is what happens when you end up with 0 over 0, which we hate. That is our indeterminate form. We haven't talked about what happens if you get zeros with trig functions. So I suggest to you to commit these two to memory. You're going to use them all the time. Also, if you haven't taken trig in a while, these parts are going to be difficult for you. You're going to want to go back and think about all of the different trig properties and things that you learned in MA 104. So for instance, let's take a look at the limit as x approaches 0 of tangent of x over x. What I can do first is know that tangent, because if I plug in 0, tangent of 0 is 0, and x plugging in 0 gives me 0. Obviously that doesn't work. What I can do first is I can break this. Tangent of x is the same as sine x over cosine x. So I just did a direct substitution. You're going to do this a lot with trig functions. So again, know what is congruent to what is equal to what can be plugged in for what, etc. Notice I've then taken it times 1 over x. Why did I do that? Because that x is on the bottom. I need to ensure that it stays on the bottom. Now again, why did I do that? Because I want to find this limit, and I can't find it right now by plugging in 0. So instead, I'm going to do some rearranging again. So notice I've just said let's put sine of x over x together and 1 over cosine of x separately, and then find the limit of each one. Now why did I do that? Because of this right here. This one tells me that if I have the limit as x approaches 0 as sine of x over x, that limit is 1. So I'm doing a replacement of 1. Fortunately for me, cosine of 0 is not 0. So it's okay that that cosine is as a denominator, because if I do direct substitution with cosine, I get 1. So my solution is 1 times 1, which is 1. And again, I did that by using this special trig limit that you will commit to memory if you are intelligent, and I know that you are. The second one, again, we're going to do a little bit more math magic, just like we did before. We're going to focus on this one, 1 minus cosine x over x. So if you want to, press pause, see if you can work this one out without me using that function. Obviously we're going to do a little bit of rearranging of this function. When you're done, press play to see how you did. So what did I do? I wanted to look at 1 minus cosine x over x. And so I took this 2 and said, that's a constant, let's move it to the outside, turned it into 1/2. Then I said, there is an x squared on the bottom, and these are being multiplied, so it's perfectly legal for me to write 1 minus cosine of x over x and then sine x over x. Now why is this helpful? Because now I can find the limit of each of those. The limit of the first is 1 using my first special trig limit. The limit of the second is 0 using my second special trig limit. 1/2 times 1 times 0 is 0, and therefore I am done with that question using my special trig powers.